Okay, this is the P4 paper from October 2022. It's question number 6, which is a differentiation question, in particular a parametric differentiation question. And what we've got is the functions defined by x equals 1 plus 3 tan t, y equals 2 cos 2t, and t is going to go between those values there. That's going to be for part B and part C, really. The range and the domain when we're working out those two. But part A then simply says, okay, if we've got this equation, can we find the equation of the tangent to C at the point P? Okay, so if I'm trying to find the equation of this tangent here, when I work out the equation of a tangent, it's a straight line. So I'm looking for y minus y1 equals mx minus x1. x1, y1 is that coordinate there, and m will be the gradient of this line. So I've explained all that to you. We now need to explain it to the examiner as we're going through and getting started. So for part A, I'm going to say find the coordinates of P first of all, just explain to them what I'm doing. So to find the coordinates of P, well, we've got y equals 0 there, haven't we? Because it's hitting the axis. So we can say y is equal to 0, and if y is equal to 0, because y is 2 cos 2t, we get that 2 cos 2t equals 0, which means that 2t is pi over 2, or in other words, t is pi over 4. So that's useful because I can use that to work out what the x value is. Remember, x was equal to 1 plus 3 tan t, so that's 1 plus 3 tan pi over 4. And if you stick that into the calculator, we get the answer 4. So we get that P is the coordinate 0, 4. So, sorry, no, it's not. This is the coordinates 4, 0. That's why we take our time with these things. P is 4, 0. If I want to work out the gradients, again, just explaining it to the examiner, to find m in my y minus y1 equals mx minus x1, m is going to be dy by dx. So reminding ourselves again, we had that x was 1 plus 3 tan t, and y is equal to 2 cos 2t. I need to get dx by dt, and I need to get dy by dt. I'm not spending any time explaining how to differentiate trig functions at this stage. You should have no problem in differentiating 3 tan t, differentiate to 3 sec squared. Differential of cos is minus sine. We've got the 2 and the 2t there, so it's going to be minus 4 sine 2t. If you're having problems with those, you'll have to go back and look at other videos and then come back to do the past paper questions. You're not ready yet. Dy by dx is dy by dt times dt by dx. And again, hopefully this is all standard stuff to you. We've got dx by dt, not dt by dx. So when I'm doing dy by dx, I'm going to get dy by dt minus 4 sine 2t, but multiplied by, just flip this one over and have 1 over 3 sec squared t. So that's dy by dx. M then is just going to be that at t equals pi over 4. So just to explain what we're doing, sine 2 pi over 4 there times 1 over 3 sec squared pi over 4, and then just put all that into the calculator to see what it comes out to be. I think from memory that's minus 2/3. And I haven't explained the equation of tangent to the examiner yet, so I'm now going to say that equation of tangent is y minus y1 equals m x minus x1, and I've got here x1, y1, and m. I've got the x1 is 4, y1 is 0, and m now is minus 2 over 3. So if I put all that in, I get y minus 0 equals minus 2 over 3, x minus 4. Just go back and check. Right, because I did sort of ignore that. It says, write your answer in the form y equals mx plus c. So, okay, yeah, I suppose we've got y equals 0 there, haven't we? So that's quite simple to do. Y is equal to, multiply it out, minus 2x over 3 plus 8 over 3, and that's the answer to part A. Right, let's go back and look at part B, or part B and part C. Now, use your exam craft here, guys. This is only worth 1 mark and this is only worth 2 marks. So I'm gonna spend quite a bit of time teaching here, but actually if you want to put these values in, part B says, what's the domain of this function? What's the minimum x value? And they're telling you the maximum x value here. So I would assume to start off with that if I put pi over 6, or rather minus pi over 6 and pi over 3, I'm probably going to get those 2 values. Now I'm going to go into a bit more detail with this, and I'm going to say let's just absolutely check to make sure that's true, because it's 1 plus 3 tan t. I can sketch it. I'm going to do a bit of work on that. But if I didn't have a lot of time, I'd just put both of those values in. Let me just explain to you why we should just be a little bit more careful than that if we've got time to do it. So we're looking basically for the domain of the function for part B. And while I'm looking for the domain of the function, I know that x is equal to 1 plus 3 tan t. So if I quickly sketch out and see what that is, let's just do it. I'll do it really, really quickly because let's say this is only worth 1 mark anyway, so I'm not going to spend too long doing this, even this was for the exam here. I know what tan looks like. Tan looks like that. And I wouldn't put any of this into my answer. Okay, so maybe I should do this in a different colour, but this bit here would not be in my answer unless I'd done everything else and was just coming back to this at the very, very end. This was my last question. Hopefully, you know that the asymptotes for tan minus pi over 2 and pi over 2. That's tan t. If I do 3 tan t, all that happens, in effect, is it just gets a bit steeper, but it's still going to look the same. So I'm going to leave it as that. And then 1 plus 3 tan t, the whole thing would be moved up just by a value of 1 there. So if I know that I've got my t values, what were they? From minus pi over 6 to pi over 3. Well, minus pi over 6 to pi over 3 is in here somewhere and in here somewhere. So I know that between those values, the end value of that and the end value of that are going to work out to be the end values of x. Now, I might not have made that too clear for you, but whether you get all that or not, let's just get rid of all that now. I can now say, right, if I want to work out what those values are, so this is what I would actually do. So if I was actually doing it, I would say, okay, if x is equal to 1 plus 3 tan t, let's do 1 plus 3 tan lots of minus pi over 6 and see what that value comes to. And that comes to 1 minus 3 root 3. If I do 1 plus 3 tan, what was the other end limit? Pi over 3. And see what that comes to. That one comes to the 1 plus 3 root 3. Now I've got my 2 values that x is going to be. I've got my my x1 here and my x2 here, there and there for what those values are going to be. They only wanted the k, so k is the minimum one of those. K is just equal to 1 minus 3 root 3 there. So if I didn't have a lot of time, I'd have done that really, really quickly without the diagram and explaining it all. Part C then is where you might lose a mark if you rush it. We're going to do basically the same idea. It says find the range of f. So the range of f is going to be, what does 2 cos 2t look like? Well, let's actually sketch that out again. Let's just move this down here. Okay, so if I've got y equals 2 cos 2t, right, what does cos look like now? So I'm hoping you know cos looks like that, going between 1 and minus 1 and all the various different values there. We're actually going from minus pi over 6 though, so we're actually going from minus pi over 6 here to pi over 3, wherever pi over 3 is. Pi over 3 will be somewhere in there that we're trying to find it. So if you then put in the values of minus pi over 6 and pi over 3, you'd get this value and this value as being your what the values go between. But look, actually, up here there's going to be a value which is higher. Now, just to remind you, this was cos t. We've actually got 2 cos 2t, so we're actually going to have a limit of 2 there and minus 2 down there if we went that far. So when I'm trying to work out the range of values that y can go between, from the graph, I know that that maximum value there is equal to 2. I know the minimum value will be whatever that one there is, which we can work out by plugging the values in. So here when we do it with the y's then, if I do y max, I'm taking off the graph, is equal to 2, and y min, I'm going to say is 2 cos 2t, and what I'm going to put in there is 2 cos, put pi over 3 in, so 2 pi over 3, and whatever that works out to be, it actually works out to be minus 1, so we actually show it's down there somewhere when we're doing it. The sketch doesn't need to be amazingly accurate here, but if you just put in the two values, let's go back to the question here, if you just put in those two values for the y, you'd have got one of them right, but you would have got the other one wrong. So that's why I've explained it in so much detail here that actually the y values go between 2 and minus 1. So doing that properly, between 2 and minus 1 would be the actual range of the function there. Okay, hopefully that last part does make a little bit of sense to you.